welcome back to the channel, everyone. Today, we're going to dive into DevCon2, the best of all DevCons. Had a great time. Got to see some OGs in the Palantir community, including Jackson from Palantir Vision, who was on my team. Lots of great product news to break down, some very exciting things in the OSDK. I got to sit with some of the senior members of the OSDK team too, to learn a lot about some features that I'm very excited to share with you. So I'm going to break down what I thought of the event, the new product announcements, the features I'm most excited about, some of the things that I'm building, and we'll go through the demo that my team built, which I think will get the wheel spinning about some of the new things you could be building on Foundry and with Palantir, including consumer applications. My team, our job was to build a consumer-focused application, and I think when we demo this at the end, you could see where this is possibly going for consumer-related products for Palantir. I'll also give my thoughts on what I think the barriers are there for them. So stay tuned, and here we go. All right, so first we're just going to dive into some major announcements by the OSDK team. So we've got media set capabilities, which are added to the OSDK. This allows you to attach videos and audio and images and PDF files to media sets programmatically. This was kind of a pain in the rear before. You could do it, but you had to reverse engineer the Foundry APIs to do it. I actually did it at last DevCon, but having this as a first-class thing in the OSDK is super cool. Next is intelligent object set watchers. This is something I'm really excited to get my hands on because it will allow you to build server authoritative applications in Foundry, meaning I can drive state from the server side. I don't have to have a bunch of disconnected states and a bunch of clients, which is actually really cool. So like this will unlock abilities for PubSub in Foundry apps. So like let's say a customer makes a change in one version of the app that's on their mobile phone or on their desktop, all other connected clients will immediately see that change. This is in a private beta, I believe, right now, so I'm trying to get access to it. But if I do, I'm going to demo it on the channel because I think this is a huge value unlock. And what it's going to enable is a lot of workflow applications where you have multiple actors, multiple systems that all need to communicate on the state of an ontology object, which drives the workflow automation. So this is really, really cool, and it allows for a more modern multi-user experience. And lastly is runtime derived properties. These are really cool because it solves overfetching problems in Foundry but previously if you wanted to do aggregations, you would have to fetch, or in a lot of cases, you have to fetch a lot of the objects client side, which isn't ideal. So runtime derived properties allow you to do to push the aggregations out to the ontology and do them there, which solves overfetching. Awesome. So the next thing that I thought was super impressive at DevCon, I think it's going to actually unlock a lot of small monopolies, like big share, small market right now for people out there in the services field or in industry, is this concept of embedded ontologies. So what Palantir did, and I'm working at a customer that's using this technology now. What they did is they created a client side that basically allow you to push your ontologies to the edge, meaning any device capable of hosting them, which is basically anything. They showed this on Raspberry Pi controllers. You can run it on smartphones. You can run it on laptops. So you'll get a local client-side copy of the ontology and the data, and you can actually run your apps offline. And this is actually a massive value unlock because offline mode is very useful in places in the world where you don't have like a stable internet connection. Like there's just not a stable network. This includes things like construction companies. Like most job sites don't have stable networks. So the idea that I could go ahead and build my application in Foundry, but then support an offline mode in the job site where it's disconnected, and then maybe once a week you have a truck go around and collect all the data, connecting all the devices, or when those devices get back to office, they can be connected to the network, and that will automatically push that data back up to the ontology, enabling all these workflows. So that's super powerful, and I'm really, really excited about the use cases. Also, there's a lot of job sites like mining operations or remote yard maintenance where there might not be a network. So like being able to power workflows in this offline mode, I think is going to unlock a whole bunch of valuable use cases that are unsupported or not supportable today. And the other thing that's really interesting about this is it could actually open the door to some very performant consumer apps, in my opinion. So like one of the bigger things in Foundry that has been tough traditionally is trying to find ways to ramp up the performance. But with offline mode and some of the things I talked about with the Foundry devs at Foundry, with Palantir devs at DevCon, was like this idea that we could have like WASM libraries embedded in the client that would then be doing a lot of this local ontology work in a super performant way. WASM is a technology that's used, it's WebAssembly. It's used to compile libraries into binary, and you can like run those natively in your browser or other device. So I think there's a future here in which Foundry could be ultra performant for consumer-based applications. And when we think about where LLMs are being pushed, which is to the edge, meaning like cellular networks and client devices, having an LLM that can run in your browser or on your device is super valuable because it solves all of the scaling problems we have today and cost problems that we have today. Like none of these things fucking make money. If you can have very domain specific models that are tailored to specific use cases for enterprise or for consumer apps, which I'll show you one in a minute, what you can do is you can like run those on the consumer's device or in dedicated hardware in a home appliance, for example, using something like what NVIDIA unveiled, right? So this edge network and the use of the ontology at the edge with the embedded ontologies now can unlock a whole range of really performant and valuable use cases, as well as a big share of a small market, which are the use cases in enterprise right now in which there is no network option, a viable network option. So this is really exciting stuff. Again, this is in a private beta, which I'm trying to get into. And if I do, I will showcase it here on the channel if it's cool with Palantir. All right, so let's jump into our DevCon demo. Our task was to build a consumer-focused app. The way DevCon works is like 2 days. You basically have 8 hours of build time to build with your team. Team's typically 3 to 4 people. And we were able to, we wanted to create a personal assistant using 11 Labs voice assist. And we wanted it running on our mobile phone. We wanted a really sexy UI, and we didn't have time for any of that. We did get to the point where we could build the assistant and have it do specific things like send email, send Slack messages, assign tasks. And then we ran out of time to build additional skills, and we ran out of time to make it look sexy or whatever. But in my opinion, this is fucking awesome to be able to even get as far as like a voice-enabled personal assistant. I can do those 3 things, and we can add skills very easily. Like I'll show you in a second the code and like how you can add skills to this. It's not hard to do, and it's all powered by Foundry. So like in the back end, the thing that's actually sending the Slack messages and sending emails and assigning tasks is all done in a Foundry compute, or it's done in Foundry. Some tasks are done in a compute module for various reasons. Others are done in TypeScript functions. And we actually have 2 Foundry stacks talking to each other, which I'll show you in a second kind of how that's done. But let's just get through a demo of the app. So I'm going to ask Vivki here to like do some stuff for me that I need done. So let's go and just start recording. Allow while visiting this site. Vivki, please send a Slack message to Dorian in the Foundry Devs channel, letting him know that the video for DevCon recap will be out later today. Also send an email to Connor, letting him know I'd like him to watch the video before it's released. And then create a task for Dorian to go ahead and create a script that demos this app for the rest of the team. And so I'm going to stop recording there, and what we're going to get is the transcript of all that. It's hard for some reason with Blueprint. You can see 11 Labs capturing the audio here. 11 Labs was really good. It was really good at like being able to deal with like background noise and all kinds of other BS that you get in the conference. It would pick up things like if you smack your lips or whatever, and it's really good at this stuff. And it doesn't seem to throw off the model. So what I'm going to do is I'm going to go ahead and submit that, and I'm going to go ahead and just pull up the dev console here. And what you're going to see is like what's happening first is we're running through this model that we trained in Foundry using in context learning off a few examples to create a solver, a task list out of that. And next we're going to go ahead and create a state machine, which you're going to see show up here on the right using another model that we trained in Foundry within context learning and some training data on how to generate the state machine from a well-defined task list. And now what you're seeing here is it's going to go ahead and get the Slack message to send which is the first state in the state machine, right? And so off to the right here, and of course, this is like a developer tool. I would never use this for consumers. Again, we didn't have time to put a sexy front end on this. I just want to show you the capabilities of something like this being run through Foundry. And off to the right here, you can see the state machine that represents my task list. And the first thing I have to do is write the Slack message. And so Vivki here has written me a nice little Slack message. I'm just going to go ahead and scroll through it real quick. Yep, she's given me a good persona. We're just going to go ahead and hit next. And what's going to happen there is that it's going to actually send the Slack message, which we will see here. And here we go. I just got my Slack message. As you can see, it's 8:42 a.m. And boom, done, right? So that's pretty cool. I got Slack messages going. The next thing we're going to do is jump over and send the email. And you can see the next state in the machine, I have Vivki's email, and she's writing it to Connor, and she's just letting him know that I want feedback. And Vivki has a persona, like we gave Vivki a persona. We trained her in Foundry as well using in-context learning, using training data we manage there. So that's great. And then the next thing I'm going to do is fire off that email. And then what's going to happen in the background is it's also going to create the task for me. So I'm just going to jump over to my email inbox here. And wait for that email from Vivki to arrive. That says process complete. And let's go and see. Oh, actually, it got sent to Connor. Never mind. I can't see it because I sent it to Connor. That's not good. I'll show you a second of the email working if I send it to myself. Let's just do Dorian here. Cool. And then the last thing it would have done for me is create the task in the Kanban board, which you see here, right? And so it went ahead and created the task in the Kanban board for me as well. And this is all live. This is not smoke and mirrors. This is actually happening in the background. All this code is going to be open source, by the way. I'm just going to release the project in case you want to use it. And now what I'm doing is I'm regenerating the state machine with myself in there so that you guys can see it actually sending the email to me. The first thing it's going to do again is redraft the Slack message. What's neat about using state machines, by the way, is we can save these solutions. So like, I'll just call this DevCon recap. And what it'll do is it's actually going to save to local storage right now, but we also saved these to the ontology, this whole state machine. And you can actually rehydrate them later and rerun them again. So if you want to rerun the same state machine, you can. And we actually have an interpreter we built for Foundry that runs these as sagas, which are going to be open source, which is really cool as well. So again, I'm just going to resend that Slack message. Next thing I'm going to do is wait for Vivki to come back with the draft email. Now she's writing it to me. We're going to go ahead and hit submit. And then the next thing that's going to happen is the email is going to be sent and another task is going to be created in our Kanban board, which isn't ideal. When it says process complete, we'll go recheck the Kanban board. You can see I have a new ticket assigned. I'm going to go ahead and just delete this old one. Well, you can see the new one here. I'll delete them in a second. But here's the new task that was created. And then I'm going to jump over to my inbox. And you can see Vivki has contacted me. And she said, happy Sunday. Please watch the video for DevCon recap. So what's cool about this is you can drive it all through voice. 11 Labs, again, their models are legit. I think I'm going to definitely be moving over to 11 Labs for all my speech-to-text and text-to-speech needs. You can also tune the model to your own voice, which is going to be crazy. Because like maybe I could make a virtual assistant that could also do some phone calls for me. We didn't get a chance to do this, but if you use Twilio with 11 Labs, I could actually drive a conversational agent through this Foundry implementation I've done for state machine management. And so that I think would be freaking amazing. Let me just give you a quick overview of the React app that we use to build this. Basically, we have this is our main text to action app that sort of handles all of the voice integration, all of this capturing of the text and running of the state machines. To run the state machine, I created this interpreter. It's a wrapper around XState that I created for my XReason framework, which is also open source, and it is responsible for running those state machines that you saw. Basically, let me just see, under this reasoning directory, you'll find this interpreter headed. It's a very small, lightweight component, and all it does is run state machines in XState v4. I haven't migrated this to v5 yet, but that's what's actually progressing you through the state machine and executing it. And then there's also the programmer. This is what actually blows the state machine DSL you saw over here. Let me close this so you guys get a better view of this. This is a DSL I wrote and trained the model on in Foundry using in-context learning examples. This has to get blown up into a real state machine language, which is over here. This programmer blows this up into an X-state compatible state machine. And we also have the ability to observe if there's logic in these task flows and use an LLM transition to reason about what the next best action to take in the state machine is based on what has happened to date and what the logic in the task definitions kind of state. We also have, let me see, I want to show you guys the actual context for comms. This is like every X reason that we run through this technology gets its own context. And in that context, this is where you define your skills. And this is how you can teach the model new skills. So this is the function catalog. We basically teach the model how it can create a task. We just tell it this. It's basically a tool definition. We say, like, here's this tool you can use. Here's what it does. And then we have the actual implementation, which is written in code. Some of these are deterministic functions. Some of them are not. Some of them use LLMs to extract parameters, etc. But anyway, you can go through this catalog, and this is how we teach the model new skills. And then for some skills can just be run as is, like that you don't need a component for the user to view, like create task. We just allow the model to automatically create the task. I don't want to review the task before the model creates them. But for other things like write emails, for example, let me just roll some of these up. And we don't need project files, status reports. Okay, so send email, no. So, but for things like write email, where we want the user to be able to review it and give input, we leave a blank implementation function here, and we just return this write email component. And what will happen is the state machine is paused at this point, and then you just define a generic React component. It could be any React component you want. You could be calling diffusion models in here. You could be building a color picker or design tool or whatever you want. It's just a generic React component. The magic happens when you call this onNext function. And what that's going to do is dispatch an event to the state machine. Say, hey, go on to the next thing. I'm done here. And that's what's happening when you would see me like hit the next button over here in the sample app. That's what's actually happening is we're calling this dispatch. So in order to teach the model new skills, all you do is you create a new context, right? You could literally copy and paste all this code. You give it training data, which we store in Foundry. We have an app we use in Foundry to maintain the examples for this application, which I could probably show you. Actually, I can't. I don't have it open. Oh, fuck it. I'll find it for you guys. Let's go to files. And what's neat is you can see, like, you don't need very many examples for in-context learning to train the models on this stuff. So if we just jump in over here. These are synthetic examples that we generated in a synthetic data pipeline of various tasks like send a Slack message, get available meeting times. And these are just ideal solutions, like a solver step. And you can see it's just in English, plain English, of like how to perform a particular action. We then use those to create our in-context learning examples where we show the model, here's a well-defined task list of things to do, and here's the state machine that represents it. And we only have to do 3 of those examples, and they get dumped into our prompt template via Foundry. And you can see here where I'm grabbing my OSDK objects for that training data, and that just gets dumped directly into our prompt examples. And that's how we're training the model on how to build the state machines and also the solution examples, solution steps, because there's both a solver and a programmer to drive this whole interaction over here, right? So very, very cool. It's not actually that complicated of a React app. I know it sounds like super intimidating or whatever, but if you're a good front-end developer, you'll pick this up right away. And what's cool is how easy it is to teach the model new skills, how to leverage Foundry in the backend to do the complicated bits. And just to kind of drive that home, like how is the backend actually working? This is the architecture. This is our CodeStrap stack. It's a developer stack that I have, which some open source maintainers use with me to build a lot of this technology. And then you have the DevCon stack, which was where our app was like hosted, and some of the other bits like AIP logic flows that Jackson worked on was stored. And everything was communicated client-side via the laptop. So this whole app is orchestrated client-side on a laptop. And then we also call out to 11 Labs for the voice integration. And these two stacks then can be leveraged in the same application workflow. And this is a pattern you can repeat over and over again. And I find this really interesting because we can create a new API economy built on Foundry around this. What I'm leveraging this stack for, again, is things like sending emails, sending Slack messages, etc. And actually, you can actually pass all of the data needed to do that in the text messages themselves. So like you can actually call out to a third-party stack that could do these things for you without having to like necessarily bring them all into your own stack. And if I show you, I think I have an example of that over here. Yeah, these are the X reason functions. Let me just roll these up. You can see all the individual functions we built out on our Foundry stack, and then I expose them over here in this comms OSDK TypeScript class that gets published, and this makes all of those functions available publicly, or sorry, not publicly, but makes all of those functions available as endpoints in my OSDK application that I consumed in our app over here, right? And so when you actually see this thing sending emails and sending Slack messages, that's actually being done through our my CodeStrap, Foundry stack, even though the app was run on the DevCon stack. And the last cool thing to point out is Palantir has VS Code running in the browser. So if you want to work in the browser, you can actually run this app. You'll see it running over here in the preview pane. I prefer to work locally most of the time, but this is actually really cool because it enables you to not have to worry as much about your laptop and your local dev environment. In theory, you could actually be mobile on any laptop if you built your development environment correctly in Foundry. You actually probably wouldn't need a whole lot for your local setup, which is kind of interesting. Currently, still, I like to do a lot of development locally, but I actually am getting more psyched on just moving over to the web-based integration, especially when Foundry is my backend, because I don't need anything else. Like, it is actually pretty liberating as a developer to not have to worry about every environment setting and setting up a new laptop every year or whatever, having to migrate everything over. Like, it's actually really, really cool to just have all of this sitting in my Foundry stack, and then whatever system I buy, my development environment is sitting up there in Palantir's cloud environment. So that's pretty cool. So that's all I've got for you guys today. I hope you understood some of this. If you're a developer, I will be publishing this whole thing open source, right? And we have CommsForge, which is coming with it. CommsForge is the integration with Google and like G Suite and Slack. It includes a compute module to send emails in Google and read emails. We also have a whole bunch of transforms that we've written that batch process all of these messages into a intelligible communication ontology type, which you can use in your applications. So look for that at the end of this month, and I will see you next time.